Hi, and welcome back to the channel. This week's problem is about trying to find the shaded area. We have got a semicircle with a triangle inside of it, with the apex of that triangle touching the outside of the semicircle, the point D. And we've got a hypotenuse of that right angled triangle of root 10 and a vertical height of length 1. Can you work out the shaded area? If you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to go through my solution in 3, 2, 1. Okay, so the first thing is I'm going to show you two methods to solving this problem. So the first method, what I'm going to do is I'm going to call the base of that triangle x. Now, because it's a right angle triangle, we can work out the one remaining side by using Pythagoras. So I'm going to do the square root of the hypotenuse squared, subtract the other length, the other side length squared. That is going to give us an answer of 3. So the base of that triangle is going to have a length of 3. Now from there, what I'm going to do is actually I'm going to put on here the center of the circle, and I'm going to introduce a radius. Now this radius is going to be a particular radius. It's not just going to be any old radius. It's going to be a radius that is going to cut the hypotenuse of that right angle triangle at a right angle. Okay, it's going to meet that length or that side length at a right angle. Now, the reason I want the radius or that specific radius is because a radius that bisects a chord, and that hypotenuse is a chord of the full circle, if it meets it at a right angle, it will bisect the chord, which means cut it in half. So that root 10 from the hypotenuse will get split into root 10 over 2, either side of that radius. Okay, now from there, what I noticed is that actually I've got two right angled triangles. I've got this blue one here, and I've got this pink one here. Now they are going to be similar right angled triangles, okay? Now, the reason for that is they're going to have all of the same angles, and so therefore they must be similar right angled triangles. The reason they must have exactly the same angles is because they share this angle at the bottom right here, and they both got a right angle, and so the third angle must be the same. Okay, now if we take those two right angled triangles, and what we're going to then do, because they're similar, is compare the sides and work out a scale factor. Okay, so corresponding sides are the base or the bottom, as we've got the triangles now, of those triangles. Okay, so the 3 and the root 10 over 2. So how do I get from 3 to root 10 over 2? Well, what I'm going to do is I'm going to times by root 10 over 6. That will give me 3 root 10 over 6, which when you cancel the numerator and denominator, you get root 10 over 2. So if we multiply the hypotenuse, root 10 of the pink triangle, by the same thing, root 10 over 6, we will get the radius of the semicircle, or the full circle. So that will give us an answer of 10 over 6, which when you simplify is 5 over 3. So let's go back to the diagram. We know that the radius here is 5 over 3. So we'll put that on. Now from there, I need to just work out the area of the semicircle and then work out the area of the triangle and take them away from each other. So the semicircle is a half pi r squared, and the triangle is a half the base times the perpendicular height. That they give us answers of 25 over 18 pi, and the triangle is 3 over 2. So our final answer for the shaded area is 25 over 18 pi minus 3 over 2 units squared. Now, I said at the start, this was one method. Another method of solving this problem is coming up. I'm going to show you that right now. So we're going to start off with the base of that triangle already calculated. So we did that before with Pythagoras. So that base is 3. Now what we're going to do is I'm going to make it a little bit smaller, and I'm actually going to take that semicircle with the triangle in it, and I'm going to flip it. I'm going to mirror it so I get the full circle. Now, what I want to work out here to get the full diameter is this length x. Now, what I can do is I can use the intersecting chords theorem here. And that says that two chords that intersect Basically, I can go from the circumference of the point of intersection times by circumference of the point of intersection on one chord, and then that is equal to circumference to the point of intersection times by circumference to the point of intersection. Now, what that means in our diagram here is that I do 1 times 1 equals x times by 3. Okay, so that will give us 3x is equal to 1. And then dividing by 3, I get that x is equal to 1/3. Put that on the diagram there. Now the diameter is going to be 3 add a third, or a third add 3, depending on which way around you're doing it. Same answer. So that gives us an answer for the diameter of 10/3. We need the radius, so let's half it so we get 5/3. Now remember, we only need to worry about the shaded area in the semicircle. So let's go back to that. So there's our semicircle, our original problem. And at this point, we're just going to do the same calculations that we did for the other method. So semicircle, half times pi times 5/3 squared. Triangle is a half times 3 times 1. That gives us 25/18 pi and 3/2. Subtract them and we get our final answer again of 25/18 pi minus 3/2 units squared. Let me know if you used either of those solutions, if you tried this yourself, and if you found another way to solve this problem, share it down in the comments below. All that's left to say is thank you so much for watching. If you're not already, please do consider subscribing to the channel. And if you enjoyed this video, please drop a like on the video. There should be another video just up here for you to click on and watch if you want to. Thank you so much for watching. I'll see you next Monday at 5 p.m. for another problem solving video. Until then, bye-bye.